Hi, Jim Shaw here from Crystal Group. Wanted to spend a moment talking a little bit about general purpose graphics processing units, or GPGPU technology. In essence, the technology has changed so rapidly that it's becoming more and more exciting. There's a lot of applications for the technology, and Crystal Group is here kind of on the forefront of taking that technology and putting it into those rugged, harsh environments. So what is a GPGPU? Well, the technology that we primarily use is from NVIDIA, and so we're using the Tesla platform, and that could be the K80s, the K40s. Some of them are even, these particular units have a fan built in, but we do have some units that are fanless, and we're able to cool those adequately. These are relatively power-hungry processing engines, and so you have to be pretty careful about your thermal characteristics and the thermal design in your box. We had an earlier variant of these where we could stick 4 of these units into a 3U server, and they were water cooled. In this particular design that we have here, this is actually 4 units that are air cooled. We figured out how to make these cards work in these environments, and so we've modified the cards fairly extensively. Let's talk a little bit about the technology and where it's going. The GPGPU platform has been changing, and it's currently sitting on Maxwell. We started at Tesla with the CUDA cores, we went to Fermi, and then Kepler, and that's what a lot of our product is that we're shipping today, is the K80s or that kind of platform. But we're also seeing some of the newer platforms like Maxwell, the M60s as an example. So eventually we'll get to Volta, and so that will be at least in the roadmap that we have today. We'll be able to see, or we're able to see the technology as it's progressing along, and they're just changing the number of cores and the amount of power draw. So essentially it's increasing the capability of the system. So where would you use this kind of thing? It might be in the sciences, in chemistry, in chromatography. It could be in seismic activity. The military is very interested in it from the standpoint of video processing, signals exploitation, and video streaming. So you'll see this kind of technology being used in those applications. For instance, you might want to take a look at a video image that you're taking today and compare that image to one that was taken yesterday, and pixel by pixel you'll be able to compare the images so that you can tell if anything's been different. Say you're flying over Afghanistan and you're looking for some place where someone's been digging, as an example. So that's the kind of things that you're using the technology for. This unit, for instance, can take up to 4 Teslas or 4 GPGPUs. The current metric by which a GPGPU is measured is in teraflops, which is floating point operations per second, or 10 to the 12th floating point operations per second. So the current K80 that we're working with today is roughly 9 teraflops. So you can imagine 9 teraflops in single precision in 4 cards into a box, get you right around 36 teraflops. We do have one unit that we're currently producing that has up to 8 Tesla cards in the system, or 72 teraflops single precision. So very, very amazing technology. It's exciting, it's changing quickly, and so we're just staying on the cusp of that leading edge of the technology, and it's really, really interesting. Thanks a lot.
Join us next time for another shiny object at Crystal Group.